Hope you all are fine and doing good. Since last session, we have seen about operation of integers under addition and subtraction and some textbook problems also. Now, we will continue the same chapter that is integer. Today, I am going to take properties of integer under addition and subtraction. First, we will see the properties of addition of integer. Before going to this topic, first of all, we will revise what we have learned in the previous class about the properties of numbers. See, we have learned that in previous class, the sum of the two whole numbers is whole number. So 2 is a whole number, 0 also whole number. So 2 plus 0, it will be 2. 2 is a whole number, 0 also whole number, 2 is also whole number. This means we have learned that the sum of the two whole numbers is a whole number. So you take one more example, 2 plus 5. 2 is a whole number, 5 also whole number, 2 plus 5 will be 7. So 7 also whole number. So as you know that this property is known as closure property of addition. Now let us see whether this property is true for integers or not. Let us see some examples here. Minus 1 is a integer under addition. We are doing under addition. Plus 2. 2 minus 1, that means 1. Minus plus minus 2 minus 1 means it will become 1. So 1. 1 is a integer, 2 also integer, minus 1 also integer. You take one more example, 2 plus minus 3. So plus minus is 3 minus 2, it will come 1. 1. So you can carry minus sign because 3 is the greatest number. In front of 3, the negative sign. So you can carry negative sign here. That is minus 1. So 2 is an integer. Minus 3 also integer. Minus 1 is also integer. Means the sum of the two integers is always an integer. So this property is known as closure property. That is the sum of two integers is always an integer. So take one more example here, minus 1 plus minus 2. So minus plus 1 plus 2 means 3, then you can carry negative sign here. So minus 1 then minus 1 is the integer, minus 2 also integer, so minus 3 also integer. Say one more example, minus 3 plus 2. Minus plus minus 3 minus 2, it will come 1. So you can carry minus sign here because 3 is the greatest number. So that is minus 1. So minus 3, 2 and minus 1. These three numbers are integers. So when you are adding these two numbers, so we will get the next. We will see the next property. Commutative law of addition. If A and B are any two integers, then A plus B is equal to B plus A. Now we will take some examples. We will see some examples here. 2 is an integer, minus 4 also integer, is equal to plus minus 4 minus 2 means that is 2. You can carry minus sign. Now you can write here minus 4 plus 2. Minus plus minus 4 minus 2 means 2 is also minus 2. Clear? So it is the A. Let us take B. That is A plus B. Here this is b is equal to minus 4, b plus a equal to 2. So that is b plus a. Means a plus b is equal to b plus a is equal to both value minus 2. We take one more example. Minus 2 plus minus 6. Minus 2 plus minus 6 is equal to minus 6 plus minus 2. Both result will be minus minus plus 6 plus 2, that is 8, that is minus 8 is equal to minus minus plus 6 plus 2 means that is 8. So minus 8. So minus 8 and minus 8. That means a plus b is equal to b plus a. So this property is known as commutative law of addition. Next we will see the next property, that is associative law of addition. See as an example, 2 plus 3 plus 5. Let us take 3 integers. 2 is an integer, 3 also integer, 5 also integer. First of all, you can add these two numbers, 2 plus 3. Then you can add 5 thereafter. 2 plus 3 means 5 plus 5 is equal to 10. Similarly, you can do the second case, 2 plus 3 plus 5. You can add 3 plus 5. At first, 3 plus 5 means that is 8. So 2 plus 8, it will become 10. Now, you can take the same number. You can add 2 plus 5. At first, 2 plus 5. 2 plus 5, that is 7 plus 3. It will be 10. All result will be the same. So, in associative law of addition, if a, b, c are any 3 integers, we can write like a plus b plus c is equal to a plus b plus c. You can add a plus b first, here b plus c first. The result will be the same. Like I have done one example here. This is 2 plus 3. 2 plus 3. 2 plus 3 is 5, then 5, it will become 10. In second, a plus b plus c, 2 plus 3 plus 5, we can add this two number, 3 plus 5, it become 8, 2 plus 8, that is 10. So that means a plus b plus c is equal to a plus b plus c. So in LHS, in RHS, the both value result will be the same. So you take one more example here. A plus b plus c, you take a is equal to 2, b equal to 4, c equal to 3. So a plus b plus c, 2 plus 4 plus 3. 2 plus 4, that is 6 plus 3 will be 9. Now you can take here a plus b plus c. You can keep the bracket within the bracket b plus c. A, the value of a equal to 2, the value of b equal to 4, the value of c equal to 3. That is 2 plus 4 plus 3 is 7. 2 plus 7 means 9. So that means a plus b plus c is equal to a plus b plus c. Both are equal in LHS side and RHS side. So this property is known as associative law of addition. Topic is additive identity. When we add 0 to any whole number, we get the same whole number. See, here one example, 0 is a whole number. You can add any whole number. 0 plus 2 means it will be 2. 2 is a whole number. You can add this whole number with 0. 0 also whole number, it will become 2. So, is it an additive identity for integers also? We will check here some examples. 0 plus, you can add 0 with any integer. You take minus 1, it will become minus 1. So 0 plus minus 2, it will become minus 2. Or you can take 3 plus minus 3 plus 0, it will become minus 3. That means for in any integer you take a, we have that is a plus 0 will be 0 plus a will be that is a. Here a is any integer, you can take any integer, that is 2 plus 0 is equal to 0 plus 2 will be 0, will be 2. You take any number here, 5 plus 0, 0 plus 5, it will be 5. So this property is known as additive identity. Now we'll go to the next, additive inverse. As we know that the opposite of any integer, a is, let us take opposite of any integer. A is, what is that, minus a. You take opposite of any integer, minus a is a. The sum of these two integers will be 0. The sum of two integers, that is the a plus minus minus, so it will come 0. So the sum of two integers, the first one is the positive integer, then second one is the negative integer, so it will become 0. So that is additive inverse of a is minus a, then additive inverse of minus a is, that is a. So we can do like that, the additive inverse. We will see the next topic, subtraction of integers. For any integers a and b, we have a minus b. For this a minus b, we can write a plus, in the previous section you are seeing additive inverse, so that means minus b. Minus b means additive inverse of b. So that is a plus additive inverse of b means that is minus b. For we can write a minus b is equal to a plus additive inverse of b. So you can write any number like 2 minus 4. 2 minus 4 means 2 plus, it is the minus 4. This is 2 plus additive inverse of 4. Additive inverse of 4 means that is minus 4. So you can write a minus minus b. A minus b. So it is the additive inverse of minus b. So for we can write a plus, it is the additive inverse of that is minus b. So for a plus additive inverse of minus b means that is plus. So first we can write a minus b, that is a plus b. We can do in a problem 2 minus 7. So we can write this one 2 plus additive inverse of minus 7. That is additive inverse minus 7 means plus. That is plus, or minus plus, that is 7. So 2 plus 7 equal to 9. So 2 minus 3, we can write 2 additive inverse of minus 3, that is plus, that is 2 plus 3, it will be 5. Now we will see the properties of subtraction of integers. First we will see the closure property. If a and b are any two integers, then a minus b is always an integer. See, a is an integer, b also integer. That means a minus b. A minus B also integer. Let us take one example. A equal to 2, A is equal to 2, B equal to 1. So A minus B, 2 minus 1. So that is 1. So A is also, 2 is also integer, 1 is also integer, then 2 minus 1 also integer. So that is it comes in the closure property. Now subtraction of integers is not a commutative. Like A minus B is equal to B minus A. Is not commutative property under subtraction, and also A minus B minus C does not equal to A minus B minus C. This is also not associative property under subtraction. We will see some examples here. For this, A minus B does not equal to B minus C. Let us take A equal to 3, then B equal to 2. You can check here A minus B. A minus B. That means A equal to 3 minus 2. It will become 3 minus 2. This is 1. Now we can find B minus A. B equal to 2 minus A equal to 3. So plus minus minus 3 minus 2 means it will come 1, that is minus 1. So that is A minus B, then B minus A. A minus B equal to 1 and B minus A minus 1. So these two numbers are not equal. That means A minus B does not equal to B minus A. So in subtraction, commutative property is not possible in subtraction. Now in associative property, we will check here associative property. Let us take example A equal to 3, B equal to 2, C equal to 1. Now in LHS side, that is A equal to 3 minus 2 minus 1. That means 3 minus 2 means that is 1 minus 1, it will become 0. So here A equal to 3 minus B equal to 2, then C equal to 1. Can do first subtraction first here. 3 minus 2 में 1 निकालना से 1, 3 minus 1 equal to that is 2. So in first case A minus B minus C, the result will be 0 if we are taking the values A equal to 3, B equal to 2 and C equal to 1. In RHS side, A equal to 3, B equal to 2 and C equal to 1. So first we have to subtract these two numbers, means B minus C. You can give the bracket, that is 2 minus 1 equal to 1. So 3 minus 1 is equal to 2. So here is the 0, here is the 2. Both sides are not equal. So it is not possible under subtraction. See the next topic, that is multiplication of integers. In previous sections you have learned addition and subtraction of integers. Now let us learn how to multiply a positive integer and a negative integer. You know that multiplication of whole numbers is a repeated addition, such as 2 plus 2 plus 2 plus 2 plus 2. 1, 2, 3, 4, 5. That is 2 is how many times? 5 times. Into you have to multiply with 2. That is 5 to the 10. See 3 plus 3 plus 3 plus 3. 3 is how many times? 4 times. 4 multiply with this 3. So this is 12. So both are positive integers. 4 also positive integer, 3 also positive integers. So 4 3 is 12, 5 2 is 10. Now we will see a negative integers. We will see negative integers under repeated addition. 1, 2, 3, 4, 5. 5 times you have to multiply with minus 2, then it will become minus 10. Similarly, minus 4 plus minus 4, then minus 4, then minus 4, is equal to 1, 2, 3, 4. How many times? 4 times. 4 multiply with minus 4, that is minus 16. So now we can see these numbers on a number line. Say minus 1, minus 2, minus 3, then minus 4, minus 5, minus 6, then minus 7, minus 8, then minus 9, then minus 10. See, already we done in previous section. Minus 2. Minus 2 means the numbers will move towards the left side on a number line from 0. That is minus 2 means you have to jump 2 steps toward the left side. That is 1, 2. That is minus 2. Again here minus 2. Again you have to jump 2 steps. Then you reach that minus 4. Again you have to jump 2 steps toward the left side on the number line. That is minus 6. Again you have to jump minus 2 towards left side. You reach minus 8. Then again you have to jump minus 2 toward the left side. Now we will reach it. That is minus 10. So this is the way we are doing repeated addition. Here the same repeated addition is we can do on a number line. Repeated addition 1, 2, 3, 4, 5. The minus 2 is repeated how many times? 5 times. Means 5 into multiply minus 2 means it will become minus 10. We can do the same problem on a number line. See here from 0 to minus 10 means you have to jump 2 steps to the left side, again 2 steps left side, again 2 steps left side, again, then again. So you have to jump 5 times. 1, 2, 3, 4, 5 times. Then you reach at minus 10. So here is the minus 10. You will see the next sum 0. I put here minus 4, minus 8, minus 12, minus 16, then minus 20. 4, 1, 2, 3, 4, 1, 2, 3, 4, that is minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8. Then like this. See. Here minus 4. Minus 4 means you have to move towards the left side on your number line. From 0, you have to jump 4 steps because here is the minus sign. Minus sign means towards left side. You move towards the left side. Again minus 4. Again you have to jump 4 steps towards left side. Again minus 4. Now reach the minus 12. Then again minus 4. Then minus 16 is here. So that is here minus 16. So in this way we can do the following sums. Now let us see how to find a positive integer and a negative integer without using a number line. See, a positive integer and a negative integer. It is positive integer, then negative integer. Let us take one example here. Find 4, the positive integer, it is a negative integer. Positive and negative. We have to multiply these two numbers. Now, first of all, before doing the multiplication of these two numbers, first you have to multiply signs here. Here positive sign, then here negative sign. Positive sign, then negative sign will become negative sign. So that means plus minus. Here plus sign, then minus sign will become minus sign. You put here minus, then you have to multiply 4 into 2. That means minus 8. See one more sum. Here 7 multiply with minus 3. It is a positive sign. 7 with positive integer. This is negative integer. Now we have to multiply first positive integer, then negative. Positive sign, then negative sign will be negative sign. Plus minus means that is minus. Then you have to multiply with these two numbers, that is 7 and 3. So that means 7 3 are 21. The result will be minus 21. Then you see one more problem. Here 3 multiply with minus 5. with a positive sign, negative sign, positive then negative, positive sign and negative sign. When you are multiplying, you get negative sign, put negative, then 3 into 5. That means 3 5 is 15. So in this way, we can multiply a positive integer and a negative integer. Remaining topics we will continue in the next class. That is properties of multiplication, division, and its properties. Till then, stay safe at home.